Consider the region enclosed by y equals cosine x and the x-axis between x equals negative pi over 2 and x equals pi over 2. Find the perimeter of the region. Don't forget to add the length of the bottom. Do not evaluate the integral portion of your expression for the perimeter. Okay, so the perimeter is going to be this orange thing, the length of that orange thing, plus the length of this purple thing. So the orange thing is easy. Let's start there. L for perimeter, L for length, I guess, is equal to, okay, so the orange thing is just pi over 2 minus negative pi over 2. That's just pi. Plus, now the arc length is a separate formula, right? It's integral square root 1 plus something squared dx. So let's fill in the limits here. So the limits are just from minus pi over 2 to pi over 2. And then the something is supposed to be the derivative. So the derivative of cosine is negative sine. So right in here, negative sine of x, it's going to get squared. You could rewrite it if you want as a 1 plus sine squared of x, but ultimately we're not going anywhere with this thing. You could type it on the calculator if you want to know what the value is, but I think we're good there. Set up an integral to find the volume of the solid created by rotating the region about the x-axis. The goal is an integral, but we're going to do slicing. Okay, so we're spinning this around the x-axis, and we're going to draw a slice, either a horizontal slice or a vertical slice. If you draw a horizontal slice, number one, that means you got to solve the equation for x, which involves taking an inverse cosine of both sides. Number two, this particular slice hits the curve twice. There's some kind of plus minus thing happening here. It's not trivial. If, however, we draw a vertical slice, then we have none of those problems. Vertical slice requires that you solve your equation for y, which we already have, y equals cosine x. And also this particular function slice, this vertical slice, hits the curve at the top every time, and it hits the x-axis at the bottom every time as we slide this slice left and right. So this is the simpler option. And we are going to take this thing and we're going to spin it around the x-axis, this whole region going around the x-axis. So here's a carbon copy, something like that. And then I'm going to draw my slice, like the mirror image of my slice. And as we take that slice and spin it around the x-axis, are we getting a disc, a washer, or a shell? So hopefully we see this is a disc. So we're just going to do the disc formula. So the volume of one slice is equal to, so all I know about discs is pi r squared h. Let's go back up and label the point on the curve at the rectangle that we chose. Let's call this guy right here x comma y. So which one of those letters is the radius of this disc? It's the vertical, which is the y. So pi y squared. And then the height is really the thickness of the disk. So what's a good name for the thickness of the disk? This distance here to here, well, that's delta x. So pi y squared delta x, which tells me that y is no good. I can only have x's because of that delta x. And so this is the moment where we change the y to be the function. And this function was just cosine of x. Still squared, still delta x. So that's the volume of one slice. We'll make it the volume of all the slices by leaving a little space and then doing a sigma. And then we're just going to copy everything, but the x's become x sub i's. Delta x never changes. We'll go from I equals 1 to n, and then truly we'd like to let the number of slices go to infinity. And then once we've got in exactly this form, we're allowed to convert to the integral. So this is the integral from minus pi over 2 to pi over 2, sweeping the slice from left to right. And then I'll copy pi, cosine, xi goes back to being x, still squared, delta x becomes dx. And we don't need to evaluate this integral. Estimate the integral from part B using left 2, right 2, mid 2, trap 2, and simp 2. So let's give this a shot. Actually, I think I'm going to pause the video and grab a screenshot of this page. Okay, so we've got our screenshot of that picture. And now we're going to start doing some rectangles. So if we're doing 2 rectangles, that means we're taking the entire interval and cutting it into 2 equal pieces. So then that middle piece right there happens at 0. And so it feels to me like we need to know the y-coordinates of each of the 3 points. So this y-coordinate is at 0, and this y-coordinate is up here at 1, and this y-coordinate is back at 0. So let's do left rectangles. So left rectangle is going to be, for example, on this interval, we pick the left-hand endpoint, which is there. And then on this interval, we pick the left-hand endpoint, which actually is at a height of 0. And so the rectangle is squished. There's no rectangle at all. It's just that line. So I think we're just doing these 2 rectangles here. So then left of 2 is, so the second rectangle had a height of 0 and a base of pi over 2. Pi over 2 plus, and then the second rectangle had a height of 1 and then a base of pi over 2. So base times height for each of them, altogether just pi over 2, which is right around 1.57. Okay, let's try right 2. So on this interval, we pick the right-hand endpoint that's up here, and then we complete the rectangle to the left. On this interval, we pick the right-hand endpoint, which is on the x-axis. So again, that rectangle is just squished. So it's just a straight line. So right of 2, it's going to be the same final answer, but let's write out the calculation. So for the first rectangle, the height is 1 and the base is pi over 2. And the second rectangle has a height of 0 and a base of pi over 2. So altogether pi over 2, which is still around 1.57. Now we're going to do some midpoint rectangles. So again, we had our 3 points which cut our space into 2 intervals, but now we need to go to the midpoints. So that means this guy at negative pi over 4 and this guy at pi over 4. And then the heights that we're interested in finding here, they happen to be the same number. Let's do this. So it's this point up here and this point up here. And so this y value, this was the cosine function, so it's just cosine of pi over 4, which is root 2 over 2, which is right around 0.707. So that's the y value. So if I'm thinking about drawing some midpoint rectangles, in this first interval, I go to the midpoint, I go up, and I complete the rectangle going both right and left. So that whole thing there is my first rectangle. And then in the second interval, I look here, I go to the midpoint, I go up to the midpoint y value, and I complete the rectangle going both right and left. So we get 2 copies of the same rectangle just because of the symmetry here. So this is mid 2. So the left-hand rectangle has a height of 0.707 and then a base of pi over 2. And then the right-hand rectangle is the same thing. 0.707 is the height, and then a base of pi over 2. And so if we do the arithmetic there, we get 2.22 approximately. All right, let's take a look at the trapezoids. So for the trapezoids, again, we're looking at our 3 points. And then the trapezoid is going to be to here, and then to here, and then typically, like if at this point right here we're not on the x-axis, like if it were like up here somewhere, then that would be our trapezoid. But in this case, the point is on the x-axis, and so our trapezoid actually kind of evolves into being just a plain old triangle. And the same thing on the right-hand side. It's that point and then this point, and so you connect with a straight line, but in this case we just get triangles. So, trap of 2. All right, so technically the area of a trapezoid is half the height times the sum of the bases. Okay, the height, these trapezoids are on their side, so the height is technically this. If you imagine, like if it looked like a normal trapezoid, it would look like that. So the height would be this thing, and then the sum of the bases would be like this B1 plus this B2. Okay, so half the height. The height is pi over 2. Times the sum of the bases. The left-hand base was nothing because the point was on the x-axis, plus the right-hand base is 1. And then we do the trapezoid on the right, which is really also a triangle. Half of the height over there is pi over 2, and then times the sum of the bases. The left-hand base is a 1, and the right-hand base is a 0. And so when we smush all that stuff together, we get the same 1.57 that we had before. Just to remind you the formula that we were using here. Area of a trapezoid is half of the height times the sum of the bases. Okay, and then the last calculation is Simpsons Rule. And all we need to know about Simpsons Rule is that it's a weighted average of mid and trap. Simp of 2. Okay, so the weights are, we're supposed to do 2 of the mids, and then we're supposed to add 1 of the traps, and then we divide by 3 always. 2 mids and 1 trap is three total things, so this is our weighted average. So we're doing 2 times the 2.22 that we calculated, plus 1 times the 1.57, and then divide that by 3. And we get something right around 2. It's not exactly 2, but to the nearest hundredth, it is 2.